Today we'll be writing linear equations and perpendicular and parallel line equations. To write linear equations from given information, we'll use two forms of a line. So the first form we've already talked about, we just need to remind you, slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. So in order to use the slope-intercept form, you have to have two things. Well, you have to have a slope, and you have to have the y-intercept. I know that seems like a little redundant, which is kind of great. I like that the form is named slope-intercept form. In order to use it, you probably need to have a slope and a y-intercept, okay? Now, the next form is called point-slope form. Y minus y1 equals m parentheses x minus x1, where m is again the slope, and x1 comma y1 is just any point on the line. Now the y-intercept is a point on the line, but the y-intercept is a special point, that's 0 comma b, right? The y-intercept. But on point-slope form, you need a slope and any point. So again, to use point-slope form, you have to have a slope and any point on the line. Next, we're going to use the appropriate form to find the equation of the line with the given information. Make sure you leave all your answers in slope-intercept form if possible. So look at the given information. M is equal to 2/5 and y-intercept is -5. What are the two things that they gave me? Well, they gave me an m and they gave me the y-intercept, which is another way of saying b. So which form am I going to use? I have a slope and have a y-intercept. Well, in this case, I'm going to use slope-intercept form because of the information they gave me, which is y equals mx plus b. So I'm just going to simply plug in the m, 2/5, x, plus b, which is -5. And I guess a better way of writing plus a -5 would really just be -5. And that's my answer. Did I leave it in slope-intercept form? I sure did, because that's the form I used. Let's go down to m equals 5 and through the point -2 comma 1. So here I have a point and a slope. Here is a point, here is a slope. So which form do you think I'm going to use? That's right, I'm going to use point-slope form, which is y minus y1 equals m parentheses x minus x1. So let's look at my values. I have an x1 and a y1 right here. So I'm just going to go ahead and rewrite the formula and plug in all the information that I've been given. So I have an m of 5, so every time I see an m, I'm going to plug in a 5. I have y minus y1. Who is my y1? Well, in this case, my y1 is 1, parentheses x minus x1. Who's my x1? My x1 is -2. So we have a red minus because there's a minus in the formula. Then we have the blue negative because the blue point was -2. Now, this is the answer to the line that's through this slope of 5 and through the point -2 comma 1. But unfortunately, this is not in the correct form. It says put it in slope-intercept form if possible, which means that I'm going to need to clean this up a bit. So I'm going to distribute here, and that gets me 5x. Add a line, change a sign, that's really 5 times a +2, which is +10. Then I'm going to add 1 to both sides, and I get y is equal to 5x plus 11. Now that is my answer in slope-intercept form. It has a slope of 5 and it goes to the point -2 comma 1. If you want to check your work, you could always just plug in -2 comma 1 for x and y. So y equals 5x plus 11, but y is +1 equals 5 times -2 plus 11, and just check to see if the left side equals the right. -10 plus 11 is 1. Yes, it does work. So this would be my check. So this truly does work. All right, let's go up to the next problem. M equals 0 and the y-intercept of -1/2. Again, I'm given a slope and a y-intercept. So which form am I going to use? slope-intercept form because of the values that I was given, which is y equals mx plus b. I like this form because it's really quite simple if you're given a slope and a y-intercept. So we have y equals m, but who's my m? 0, times x plus a b, which is negative a half. Now, no one really writes 0x, so we can multiply that out to 0, so y equals negative 1/2. Is that written in slope-intercept form? Well, as much as possible with the y all by itself. All right, last problem. We have a slope in green right there. We'll do my point in blue. So if we have a slope and a point, which form are we going to use? Point slope form, which is going to be y minus y1 equals m parentheses x minus x1. So y minus y1, who's my y1? Well, my y1 looks like a negative 2 equals m. Who's the m this time? Negative 3/5 parentheses x minus x1. And who's my x1 again? Negative 4. So the blue values, negative 2 and negative 4, came from my x1, y1. The green, negative 3/5 is my slope. So all I did is plug everything in. Now, technically, this is an answer. It's just not in the form that they were asking us for. So we're going to clean this up a bit by distributing, combining like terms, solving for y. So negative 3/5 times x is negative 3/5 x. Negative 3/5 times positive 4, that's a negative 12/5. If you need to do that off to the side of your paper, you multiply your tops to get negative 12, multiply your bottoms to get 5. And then I have y plus 2. So I'm going to subtract 2 on both sides to get y is equal to negative 3/5 x. Now, if I knew what that was in my head, I would be done. I would just move on with my problem after I added them. But because I don't, I need to take a little bit of extra work on the side of my paper. I need to find an LCD of 5. So I'm going to multiply the second fraction by 5/5, which is 10/5. The first fraction, he's already a 5 in the denominator, and I want a 5, so he needs to stay 5. So I can either multiply by 1 or just bring it down, either way. So this gets me negative 22, and the denominator 5 stays the same. That can't reduce. So my answer is y equals negative 3/5 x minus 22/5. And that is my final answer in slope-intercept form. Again, you can check it. I'm running out of room, so I'm going to leave that check to yourself. Notice that both forms that we've just used need slope in order to write the equation. So here's a question. What if you were not given slope? Let's just say you're given 2 points but no slope. So here's the following steps that you're going to use. First, if you're given 2 points, you need to find the slope so that you can have a slope. And we have a formula for that. M equals y2 minus y1 over x2 minus x1, which we've already used in the past. So we use the slope formula to get a slope. Then pick 1 point. Now clearly you had 2 points, but you only need to pick one of them and use one of the points with your slope in the point-slope formula, and then finish like we just did on the last 2 problems. So here's an example where you're just given 2 points. So my game plan, step 1, is to find the slope. My step 2 would be to use that slope and 1 point to get an equation using the point-slope form like I already did, and then I need to clean it up a bit just like I already did. But here's my big game plan. Find the slope first. So to find the slope, I'm going to label this x1, y1, x2, y2. One big mistake students will make is just rushing through this and putting the y in, or the x's in the wrong spot. And then that messes everything up. So we have y2, which is 7, minus, because there's a minus in the formula, y1, which is 3. And the denominator x2, which is 4, minus x1, which is negative 1. So when I subtract, I'm getting 4 on the top and a positive 5. So my slope is positive 4/5. Now the whole point of step 1 to get the slope was so that I could use the slope in the second step. So I also need a point, 1 point. Well, which point do you like better? It doesn't really matter to me which point. Usually I let my students pick, but since this is a video, I'll go ahead and pick. A lot of times my students prefer the ones without negatives. It doesn't really matter, whatever you like. So we have y minus y1. Now that we have a point and a slope, we can use point-slope form. So we have y minus y1, and my y1 this time happens to be 7, equals m, and my m was the 4/5 from the red step, parentheses x minus x1, and my x1 that we chose was 4. Okay, so this should be a solution, but in order to put it in slope-intercept form, I'm going to distribute. So I have 4/5 x minus 16/5. I'm going to add 7 to both sides. That might not be something we all could do in our heads, so I have negative 16/5 plus 7 over 1. I get an LCD of 5. So I'm going to multiply this by 5 to get 35/5. So multiply that one by 1 over 1, which gets me negative 16/5. Negative 16 plus 35, that gets me positive 19/5. So my answer here, I'm running out of space, is going to be y equals 4/5 x plus 19/5. All right, let's do that one again. So we have find the slope again as my first step. My second step is to use the slope that I just got and one of the points to get an equation. Again, I'm going to make sure that I label my points x1, y1, x2, y2, so that when I use my slope formula, I don't make any mistakes about putting things in the wrong spot. So I have negative 1 minus y1, which happens to be negative 4, over x2, which is negative 5, minus x1, which is 3. Add a line, change a sign. I'm getting positive 3 on the numerator and negative 8 on the denominator. Again, I used that formula just so I could get my slope, so that I could use my slope in the second equation. Alright, so both of these have negatives in them, so you're just going to have to pick whichever one you like better. I'll go ahead with 3 comma negative 4, and then I'm going to use my point slope form now that I have a point and a slope. I couldn't find the equation with 2 points, but if I found the slope, then I can use the slope and 1 point. So y minus y1, in this case my y1 happens to be negative 4, equals m, which is my negative 3/8, parentheses x minus the x1, which happens to be 3. Okay, now I'm going to distribute. I get negative 3/8 x plus, and negative times a negative is a positive, 9/8. Add a line, change the sign, that's y plus 4. Last step is to subtract 4. So I have y is equal to negative 3/8 x, and then I don't know what that value is, so I'm going to have to do some work on the side of my paper. I have positive 9/8 minus 4 over 1, LCD of 8. So I'm going to multiply the numerator of the second fraction and the denominator both by 8, or 8 over 8, which gives me 32. The first fraction you can multiply by 1 or just keep it the same. And 9 minus 32 is equal to negative 23/8.